When you start working on proofs in geometry, you're going to come up with a lot of reasons that seem to repeat themselves from problem to problem. This first one, I'm sure you recognize. This is the reflexive property. This is anytime a shape shares a side. In this case, the two triangles are sharing this side. But when you get to the actual proof and you have to write it down, you need to know that this is always true. This is like a definition. They don't have to tell you in the given information that there is a shared side. They might, but they don't have to, and you can still use it. So you just go ahead and go for it. Segment AD is congruent to segment DA, and the reason is reflexive property. Another definition is vertical angles. You're allowed to use it even if it's not in the given information, and our vertical angles are here. And how we write this, the two angles are congruent, and the reason is it's because they are vertical angles. And one more definition type of thing, and that is right angles, all right angles are congruent. And again, that is a definition. It doesn't have to be in the given information for you to use it, but it might be. So we're just going to go with angle C is congruent to angle D, and that is because right angles are congruent to each other. All right, now from now on, these are not definitions, and so in your proofs, you have to be a little more careful how you use them. So if you're told about a midpoint, D is a midpoint of BC. That results in two segments that are congruent. So here's D, here's segment BC, so then we know these two segments are equal in measure. They are congruent. In your proof, you have to start by stating the given information. You can't use the idea of a midpoint unless it's already written down here. That is given. And now we can use it. BD is congruent to CD, and the reason is definition of a midpoint. Alternate interior angles. You're going to look for these whenever they tell you about parallel lines. They're not going to say, look for these angles. They're just going to tell you that two lines are parallel. And you can use any of the angle pairs when we had two parallel lines in a transversal. Correspondings, alternate exterior, whatever is going to work. But more than not, it's going to be alternate interior angles when you're talking about two triangles. And so I've got those two. And so in your proof, you have to write the given information first. That is given that AD is parallel to BC. So then we write that angle ADB is congruent to angle CDB. Alternate interior angles are congruent. Segment bisector. This line is bisecting A to D. It goes through right here at K. That means that bisector is splitting this into two congruent segments. In your proof, you write your given information so that you can use it. And then we go with AK is congruent to DK because that's the definition of a segment bisector. Bisector, but this time it's an angle. So this segment in the middle, AC, is bisecting the great big angle A into two little congruent ones. We got AC is bisecting angle A, that is given information. So then angle BAC is congruent to angle DAC, and the reason is going to be definition of angle bisector. Perpendicular bisector. AD is a perpendicular bisector of BC. Well, this is giving you a couple pieces of information. Not only is it going to be splitting up this triangle side on the bottom into equal parts, it's perpendicular, which means it also creates two right triangles. All right, so let's write in AD is perpendicular bisector of BC, and that is given. BD is congruent to CD, and that is definition of a perpendicular bisector. Substitution property. If two things are congruent, you can replace one with the other. Seems pretty straightforward, but it can cause some confusion. What does this mean? If A is congruent to B, then you can do this. You are allowed to replace angle B with angle A, or vice versa. In your proof, if you need to pull a switcheroo, it's going to be the substitution property. So let's write down our given information. We know that A is congruent to B. That is given. We are told that B is supplementary to C. That is also given. Well, we're going to pull a switcheroo right now. If A is congruent to B and B is supplementary to C, then we can say that A is also supplementary to C. And the reason we do that is the substitution property, which can be straightforward, but can also get confused with this one, which is called the transitive property. If A equals B and B equals C, then A equals C. Transitive property is for just equality. In that last example with substitution, we were talking about angles that were supplementary. We've got angle G is congruent to angle H, and angle H is congruent to angle K. So in a proof, you're going to write down your given information. So if A equals B and B equals C, then A equals C. It's a property of equality. In this case, we're talking congruence. So if G is congruent to H and H is congruent to K, then G is congruent to K, and we'll call that the transitive property. Supplementary angles. If you have this showing up in a proof and your given information is that B is supplementary to C and you need to do something with that, it usually means you're going to have to switch this up from something that is just using the name of the angle to something that's talking about the measure of the angle. If you're told that these two angles are supplementary, that means you have to make a math equation. And if you need a math equation in your proof, here it comes. The measure with the little m of angle B plus the measure of angle C equals 180 degrees. And we say that because of the definition of supplementary. Again, not a full proof, just a piece of the proof for dealing with the given that two angles are supplementary. It's going to work exactly the same way for complementary. It's just the numbers are going to be a little different. So B is complementary to C, that is given, and then when we add their measures, they're not going to add up to 180, they add up to 90. That is a definition of complementary, and that's how you handle that when you see that coming up in your proof. Most students think these two things mean the exact same thing, but in a proof, this is like using the name of the angle, this is using the measure of the angle. Definition of congruent. Again, nitpicky stuff that drives people crazy. Congruent things have equal measures. Well, how do you deal with that in a proof? I'm telling you that angle BAC is congruent to DAC. This is a statement of congruence using the names of the angles. That is the given information. You say the measure of angle BAC is equal, not congruent, equal to the measure of angle DAC. And that is the definition of congruent. Yeah, I know. I totally get it. Like I said, nitpicky, hair splitting. I just want you to be able to do well on your proofs and you get to these, especially get through this unit and get a good grade on your quizzes and your tests. And this kind of stuff, you can lose points that you don't need to lose. If this was helpful, I would love it if you would share this with people so that I can help more people. And it also helps me grow on YouTube. But I really do want to get this out because not every geometry teacher has the time to be able to go over all of this stuff. And this video could be super helpful. Thank you guys. Bye.